Okay, let's talk about machine learning. You hear that term everywhere, right? But all the jargon, it can feel like you're trying to crack some secret code. What if you could crack it? Well, today, we're doing just that. We're going to decode the 5 key terms that are the absolute foundation of this amazing technology. So let's dive in.
So, where do we even start? Well, it actually begins with something you probably see every single day. You know that moment when your email client just knows to put a weird message in the spam folder? Or when a streaming service recommends a movie that you actually end up loving? Yep, that's machine learning working behind the scenes. But how does it know what to do?
That's the billion-dollar question, isn't it? How does a machine learn anything? But here's the thing, it's not magic. Not at all. It's a really logical process that's built on just a few core ideas, and we're going to walk through them together, one building block at a time. Let's start with the absolute basics, the raw material.
Okay, just like baking a cake, if you want to learn something, you need ingredients. You need stuff to learn from. In the world of machine learning, this information comes in 2 main flavors, features and labels. Think of them as the flour and sugar for our recipe. And to make this super clear, we're going to use one simple example the whole time, predicting the price of a house.
All right, first up are features. A feature is really just a single piece of information, an input, that's it. For our house price example, the features would be things like, how big is the house in square feet? How many bedrooms does it have? Or what neighborhood is it in? They're basically the descriptive details of the thing we're looking at.
Okay, so if features are the questions, then the label is the answer. The label is the correct output, the right answer that we want our machine to learn how to predict. So going back to our house, the features are all the details about it. And the label, that's the actual price it sold for. It's the ground truth we use to teach the machine. And this slide lays it out perfectly. Check it out. On the left, you've got the inputs, our features, size, rooms, location. And on the right, you've got the answer we're aiming for, the label, which is the selling price. The entire goal of machine learning really is to figure out the hidden connection between the two. Can it look at those features and accurately predict that price?
All right, so we've got our ingredients. But, we need a chef, right? We need something that actually does the cooking, something that can take those features and labels and find the relationship between them. That something is the absolute heart of any machine learning system. It's called the model.
And honestly, the best way to wrap your head around a model is to think of it like a brain. It's not like old school programming where you give it a huge list of rules to follow. No way. Instead, it learns directly from all the examples we show it, all those houses with their features and their labels, kind of like how we learn from experience. Now, if you were to look under the hood, a model is basically a big mathematical engine. Its whole job is to comb through thousands or even millions of examples to find the hidden patterns. It's trying to learn exactly how things like house size and location tend to impact the final selling price. Okay, recap. We have our ingredients, the features and labels. We have our engine, the model. So now what? Well, now comes the fun part, the actual learning process. And this phase is called training. This is where the model goes from knowing nothing to becoming an expert. So how does this training actually work? It's basically a loop. It goes like this. First, the model looks at a house's features and makes a guess, a prediction about its price. Then it compares its guess to the real price, the label. It sees how wrong it was, and then, and this is the most important part, it adjusts itself. It tweaks its internal math to try and make a better guess next time. And you gotta understand, this isn't a one-and-done deal. The model does this over and over and over again, thousands, sometimes millions of times. With every single cycle, its predictions get just a little bit better, a little closer to the truth. It's a slow process of trial, error, and correction. And that is what makes machine learning so different. We're not telling it the rules, we're letting it discover the rules all by itself from the data. All right, so our model has gone through all this training. It's studied, it's learned, it's basically an expert now at predicting house prices based on the data we gave it. But so what? What's the whole point of this? This is where the final piece of the puzzle slots in. It's called inference. Inference is, well, it's the payoff. It's the moment we take our fully trained model and give it a brand new problem. Data it has never ever seen before. It's like its final exam. We give it the features of a new house, and it has to use all the patterns it learned during training to make its best prediction. And this is the part of machine learning you actually interact with every single day. When a website gives you an estimate for a house's price, that's inference. When a brand new email gets flagged as spam, that's inference. Or when your phone recognizes a face in a new photo.
Yep, inference. It's the trained model doing its job in the real world.
So, we've walked through all the pieces, right? We've got features and labels, the model, the training process, and finally, inference. Let's put it all together now and see the complete picture from start to finish.
And there you have it, the whole story in 4 steps. You start with your raw ingredients, the features and labels. You create your learning engine, the model. You teach that model using all your data, which is training. And finally, you put that trained model to work to make new predictions. That's inference. From data to decision, every single step just flows right into the next.
And that, right there, is the big takeaway. Machine learning might sound super complicated, but once you get this core vocabulary down, everything else, all the crazy algorithms, the different coding libraries, it all becomes so much easier to understand. You now have the fundamental language to navigate the entire world of AI.
So I'm going to leave you with a question. You now know the basic recipe for teaching a machine how to solve a problem. It doesn't matter if you're trying to predict stock prices or identify diseases from medical scans or even get a machine to create art. The fundamental process is exactly what we just walked through. So the only real question left is, what problem out there are you curious enough